Morning everybody, I'd like to welcome you to the Airospring Pro presentation. Okay, good. So today we're here to talk about Airospring Pro, which is a new technology. My name is Charles Wood. I'm the Managing Director of Boltex, based in the UK. We're a technical textile business. We've been existing for 187 years, and we jointly developed the Airospring Pro technology with the University of Bolton. So what we're going to talk about this morning is Airospring Pro and its role in pressure care, and how we see that this new technology has a significant contribution to make towards the pressure care area. Airospring technology is a technical textile development which was sponsored by the UK government, by Innovate UK. It's actually the result of 6 years of academic research which was conducted at the University of Bolton. And technical textiles is a very rapidly developing area, part of material science, of which the UK is a leader. The industry represents £1.2 billion of economic activity. And as I say, Airospring is a technical textile technology which came out from that material science innovation. Pressure sores, I'm sure as a lot of you know, continue to be a major problem for the NHS, costing somewhere between £2 and £3 billion per year in treatments alone. The novel Airospring technology can actually make quite a valuable contribution to our society. It was developed, as I say, with Professor Subhash Anand and supported by Innovate UK. We had 3 successful research and development projects and a PhD program. And later on today, we'll be hearing from Dr. Carol Hepburn, who completed her PhD program at the University of Bolton. We've got 1 patent granted, and we've got 2 patents actually currently pending. The technical term for the Airospring Pro technology is 3-dimensional knitted fabrics used for pressure relieving cushions. Some of the features and benefits of the Airospring Pro technology: first of all, it's actually machine washable at 60 degrees, even 74 degrees, which I know is the healthcare standard. So any product can be washed in hospital. There is no dimensional change, less than 1%. That makes it unique. All the PU memory foam products which are out there, if they're contaminated for whatever reason, if the cover breaks down, for example, and some liquid gets inside, they have to be disposed of. That is not the case with Airospring. They're totally machine washable. The actual product itself works by a whole series of thousands and thousands of little micro springs, which actually provide proper support. It's the next generation of materials on from memory foam. It helps the microclimate because the materials are totally breathable. They're entirely porous, and therefore air and moisture can pass between them. Can we close the door, please? Can we close the door, please? Thank you. They have superior elastic recovery, and we will see that later on. They're also isotropic, which means that they actually perform the same way in all directions. Morning, Dawn. They're also very effective in terms of pressure redistribution, and in fact, we've got much better results using the Airospring Pro technology than we have using traditional polyurethane cushions. Just to dwell on a little bit of the science without going into too much of it, you'll see a diagram of the circle with the arrows underneath it, and this describes the near hydrostatic support. So what Airospring Pro does is it takes the shape of the body and adapts to it, but also it pushes back, it provides some support. So it's sort of like semi-floating in water, in a sense. With memory foam takes the shape of the body, but actually stretches the skin, which is not good in helping to assist pressure ulcers. Some of the more sophisticated cushioning systems, of course, use gels and other different types of foam to avoid some of these problems. With the Airospring Pro technology, that's not actually necessary. And on the left-hand diagram, we can see a picture diagram explaining how if a body mass is seating on a support medium which is not suitable, after time that actually bottoms out and the pressure is transferred. And that's what we see with certainly some of the lower grade cushions which are on the market today. As I mentioned earlier, Airospring Pro is also entirely breathable. So it actually allows both air and moisture to pass through. And there is no other equivalent material that we know of today which provides that type of performance. Another benefit of Airospring Pro is its superior elastic recovery. This chart shows what we call the hysteresis. So it's the elastic recovery. The blue line you can see is actually the 3D spacer fabric, the Airospring Pro material. And so when a pressure is applied and that pressure is removed, then immediately the material recovers very quickly. Compared with foam, it takes a lot longer before that load is actually starts to be effective in terms of taking the pressure, and then it takes the pressure, but the recovery, in other words, the closer these lines are together, the more performing they are. So there's a much lower recovery time. So that means it's not as springy, it's not as elastic, it's not as high performing in this case. The last one is a wadding, which takes a very long time to absorb the elastic load and works initially, but then fails. We spend a lot of time, Dr. Carol Hepburn, I say, is going to make a presentation later on about some of the postural support cushions that we've developed. But we've spent a lot of time actually doing the pressure mapping. We've got one of the only rigs at the University of Bolton which actually does it empirically towards the new wheelchair standard. So we've got a pressure indenter and we apply various different loads to that pressure indenter to actually measure the pressure mapping. As many people in the healthcare world will know that pressure mapping can be quite a dubious subject. You can get one set of results which look good, but we don't know who the patient was, what the condition was, which wheelchair was used. There are so many variables. So we've tried to strip all of those variables out by actually having a proper test rig with some empirical evidence, and we will come onto that later on in the presentation. Another aspect of Airospring Pro, both the cushions and the mattress toppers, is that they are made from polyester fibers. As I mentioned already, fully machine washable at 74 degrees. The viscoelastic foam, memory foam, can be recycled into carpet backing, but actually the scope for recycling these materials are very limited indeed. Airospring fabrics can be made from recycled polyester drinks bottles. There are a number of companies in Europe who are promoting this, taking drinks bottles, recycling them back into polyester thread, which then can be used successfully throughout the textile chain. We're already involved in this. We're already manufacturing some fabrics which are from recycled material, and also the beauty of Airospring is the product can then be recycled again because it's polyester, so it's totally recyclable. Airospring Pro also includes some FR barriers to meet the Crib 5 requirements, and this is some know-how, some specialist work that we've done. Boltex, the company behind it, has a very strong history of working within flame retardancy. We've got a lot of experience in that area, and we've worked very hard to ensure the absolute compliance of these products to Crib 5. And I think it's fair to say that we're the only people to do that within this type of product. Just talking a little bit more about sustainability, some of our plans for the future. We've got a project called Airospring 2020, where we're actually looking forward 2 years to try to present our vision for what the brand will be in the future, and sustainability is definitely going to be an important part of that. So in terms of actual energy consumption, using recycled polyesters actually reduces the amount of energy which is consumed, and if we can then get recyclability as well with our partners, with the people we're working with, then we're moving in the right direction. So it's our intention actually to increase the amount of recycled polyester that we've got in these products over the next few years. So there have been many academic papers that have already been published. As I say, we've got some patents both granted and also in progress as well. The major conclusions from all of the academic work which has been done is that the warp-knitted spacer fabrics, the Airospring technology, shows very good linear compressibility in the compression phase, which is absolutely perfect for the pressure care area. The materials also retain their thickness better than polyurethane foams over longer periods of time, and this is due to the superior resilience of the material. They're also much better at reducing peak pressures than PU foam. A lot of work has gone into the actual specific engineering of each of the layers which are actually used within the Airospring product. Airospring technology distributes pressure evenly over a much larger area of the cushion or seats than polyurethane foam. I'm just going to, there we are. I'd just like to take a couple of minutes to front. Okay. Right, Warren, over to you.
Thank you very much, Charles, for that introduction. Some of you may know me, most of you probably haven't seen me before. I'm Warren Payne from the company Polymoric, Business Development Manager. We're working closely alongside Charles and Airospring to take this product to market. So my role here today is to give you a bit of background into what we are, what we do, and what working with us would be like. So we have a very simple mission and vision. So our mission is to create products that provide support and physical independence for the aging population to enhance the quality of life of every individual by maintaining their freedom and dignity within their own familiar surroundings for as long as possible. So what we're looking to provide is, in a short way, is providing solutions. So we're bringing quality products and unique products together to provide solutions that nobody else can properly provide. So with our vision, so we envisage a world where the needs of the aging populations are recognised and provided for through innovation and development. So that's where working with the likes of Airospring, bringing the innovation to the market. So you have products which provide better solutions and better user experience. So there's two parts to Polymoric. The first being that we are a manufacturer of daily living aids. So you've got there the 6 products that we manufacture ourselves. And then for a second part, we are a distributor of new innovative products. So you've got the 3 main products there that we distribute for the likes of Airospring. Now, obviously we're here to concentrate on Airospring. So we are the distributor of the Pro range of this product, which is stands for Pressure Relief Optimized. And this is been designed specifically for use in care environments. So you have certain regulations that you need to be attained to. So for instance, what Charles referred to as the FI interliners, so that attains to the fire regulations. You've got the fact that it works so well on pressure ulcers with the benefits of it. You look at the fact that it's breathable, it's washable. All this come together to create a product which is not only beneficial to the user, but it's also beneficial to the care home or the hospital that are using it. So we've got the existing products that Charles has been through, so the AS 100, 200, 300 and 400, the mattress topper, but then we're also looking into new products along with Airospring. So we're continuing to innovate. So if we find somebody who has a problem, we would look for the solution. So recently we came up with the bath cushion. Now that has been put into motion. We've got a prototype made because there wasn't anything for people to access with, for use in the bath. Now, although it's for a very short period of time, it's still long enough for somebody to, for pressure ulcers to start. So that's somewhere that needed looking into, and we created a product for that. So a bit of a background history. We obviously haven't been around as long as Airospring. We've been 35 years. Polymorph has been in business. Now we took on the management of the business in 2015 and took on the distributorship of the Airospring range in 2017. Now it started off as providing moving and handling solutions for special needs children, and obviously we've continued with the mantra that was set out in the beginning, that it would be quality products. We have changed obviously slightly the direction because now we're doing moving and handling solutions for the elderly people, but the products that were created by the original founder are still the products that we use today. So that shows the quality and the fact that they provide a solution. So obviously you know who I am, but there's also Howard Payne is the managing director of Polymorph, and we together are partners in business and we run it. So what does the future hold? Well, obviously we've got the Airospring Pro range and we're continuing to innovate, and I think that's what is so important, is that we don't stop innovating, because I think there'll always be new problems that arise, and we have got to be there to provide the solutions. I think that brings
So good morning. My name is Dr. Carol Hepburn, and I'm here to present some of the research I carried out on recent advances in contour three-dimensional spacer pressure relieving cushions for the prevention of pressure ulcers. I'm going to start with looking at pressure relieving cushions and looking at pressure ulcers in particular. So in 2013, over 28,000 deaths were attributed to pressure ulcers, and as the population grows, this number can only increase. So what are pressure ulcers? These are areas of damage which occur to the skin and tissue, causing impaired blood supply and tissue malnutrition, which is resulted from prolonged pressure, friction, shear and moisture and heat. This occurs in the vulnerable parts of the body and in the seated or lying position. From this diagram, you can see the four main areas where this can occur. The back of the head, shoulder blades, sacral area, which includes the buttocks and the hip area, and the hip. The most important of this being the sacral area, which can account for up to 50% of pressure ulcers which occur. Of course, these mainly are affected in the seated position. So, what did we do about this?
Hi, Charles.
So, we're going to look at 3D spacer cushion.
Okay.
So research carried out at Bolton was looking at polyester warp-knitted spacer fabrics and their use in developing pressure-relieving cushions. And as Charles intimated earlier, this began with a series of flat spacer cushions, using the basic characteristics and properties of knitted warp-knitted spacer fabrics, which has been extensively researched over a number of years by many different researchers. Some of the main properties in spacer fabrics are extremely good at regulating heat and moisture. They're breathable and hence can be very comfortable at transporting water vapour and evaporated heat around the patient, thus making them feel much more comfortable. Some initial research occurred with the initial products, the AS100 and AS200, which was mentioned earlier, using a variety of able-bodied live test subjects. The diagrams you can see here show the first diagram showing a seated person on a wheelchair only with no cushion. So the red area shows the extremely high peak pressures that occur when you sit on a wheelchair with no cushion at all. The next two diagrams show AS100 and AS200 sitting on a wheelchair, showing that peak pressures in the area of the seated area is quite low, being blue and green areas, and extremely lower than sitting on a wheelchair without any cushioning whatsoever. So the main difficulty I needed to overcome in this research was that initial research occurred using live subjects. One of the things we found difficult was that using live subjects meant that there would be a lot of movement, load changes, different angles and position changes, breathing, even a person's BMI would make a difference. This created a variety of variability from test to test, from person to person, from product to product, and it was very difficult to capture data from different cushions to characterize each cushion. It was decided, therefore, that a different methodology would be used as a simulation methodology using a rigid cushion, a loading indenter, which simulates the bottom sitting on a cushion using a pressure mapping system to record data. This next slide shows the equipment that was used using a rigid cushion loading indenter, which was created at Bolton, and a universal tester, and computerized using a laptop to capture all the data, both numerically and using imagery. So these two images show a live person sitting on a cushion on a pressure map, and the second one shows the simulated pressure map using a cushion loading indenter. There is not a lot of difference, but the second one is much more controllable. So initially we were looking at how we were going to reduce the peak pressure on the human body in the most vulnerable area, which is the area at the back of the cushion where the person sits, which incorporates the ischial tuberosities, the IT, which is the most vulnerable area of the body. And these two diagrams show the pressure that is exerted at the back in the IT area for the AS200 Pro and a PU viscoelastic foam cushion, wheelchair cushion, and the difference of the amount of peak pressure that occurs in the IT areas. Average peak pressure in the Airospring 200 Pro is 39.8 millimeters of mercury in the IT area only, and in the foam cushion, 74.29 millimeters of mercury in the IT area only. A great increase. This second one can also shows also with a viscoelastic foam versus the AS200 cushion. Also at a load of 75 kilograms approximately, or 12 stone, loaded for 15 minutes. So, using this methodology, the AS200 was characterised using this test methodology to see what sort of data could be collected using the simulated method. And these are a variety of pressure mapping profiles for AS200 Pro at loads of 8 stone, 12 stone, before or initially when you apply the load, and after 15 minutes loading. So we have the AS100, an overlay cushion, which is used in incorporation with a secondary cushion, and the AS200, which is a wheelchair flat cushion. So we need to look at how we needed to protect the itch-shielded porosities more effectively and maintain a good therapeutic posture. So the development of the contoured wheelchair cushions was looked at for this main part of this research. As we mentioned before, the most vulnerable part of the body in a seated position is the itch-shielded porosities at the back, the ITs, and the thigh area, or the trochanteric shelf, which is the thigh, which is much more able to withstand higher pressures than the ITs, were two areas that we need to look at. So the first prototype cushions in the prototype contour cushions was looking at creating an effective recess area at the back of the cushions that could protect the ITs. Using a variety of layered spacer fabrics of different densities, we were able to create a variety of recesses in the prototype cushions of different depths. This diagram shows how the human body will positioned on these initial prototype cushions. These initial prototype cushions only had a recess at the back. They were flat mainly, but with the recess at the back to see how we could protect the ITs. So this diagram shows how the body would sit in the recess cushion and be protected from high pressure points. This next table shows the different characteristics, the data of what each cushion is made up of. So the two prototypes for spacer fabrics were made up of 5 layers. The 2 foam cushions that we used as comparisons were made up of 1 layer of viscoelastic foam. So our first prototype, which went forward for further development, was the ASD prototype wheelchair cushion with the recess at the back. This shows a loading of 12 stone after 15 minutes, showing an extremely low pressure area at the back of the cushion where the ITs would be positioned. And we were able to collect data that represented a mean value of 24 millimeters of mercury at peak area in the IT area only. Looking from the diagram, you can see that we have transferred the higher pressures from the vulnerable area to the less vulnerable area, being the trochanteric shelf, which is the thigh area. In comparison with the PU foam, you can see after 15 minutes at a load of 12 stones, the peak pressure in the IT area is extremely high and came out as 101 millimeters of mercury at peak pressure in the IT area only. So in comparison with a partially contoured cushion, compared to a flat cushion, a contoured cushion with a recess at the back basically was a much more effective cushion at protecting the vulnerable part of the body in a seated position, being the IT area. So using the original prototype of the ASD4, which was just a recessed cushion, we went on to create a fully contoured cushion. These became the AS300 Pro and the AS400 Pro, using the development from the original development of the recess area. We created a recess at the back to protect the IT area, but we also included the adductors and the abductor features, which were the main features to control and create a very supportive cushion, supporting the person in a very therapeutic position, particularly in a person in a wheelchair who was unable to support themselves in a good seated position to reduce slumping, sliding forward, etc., and be able to protect the vulnerable areas. This diagram shows the features at the front of the cushion. So we have the adductors in the middle, which keeps the knees apart, and the abductors at the side that pushes the knees in and the sides in, so that they keep them in a upright seated position. So when tested using our simulated methods, we had mean values for the AS300 Pro of 35 millimeters of mercury before at initial loading, and then after 15 minutes, 40 millimeters of mercury loading at our 12 stone level, up to 24 stone, which gave us mean values of 59.4 at initial loading and 56 after 15 minutes. These results are based on the average pressure across the whole cushion. For the AS400, we looked at a much higher loading, so we started off with 12 stones and went up to 40 stones to see how loading behaved on these cushions, both initially and after 15 minutes. So we were able to get mean results of up to 75 millimeters of mercury overall the whole cushion. However, the most important part we were looking at was what happened to the cushions in the IT area. And what we could see from the pressure profiles is that the pressure only in the IT area was much lower, which was what we were hoping for, and that we were able to transfer pressure from the back to the front to an area which was able to stand a slightly higher pressure than the vulnerable area. So AS400 Pro, this at a loading of 75 kilograms and 100 kilograms, up to 16 stone. We can see that still in the IT areas, we have still got areas of lower pressure. And the same up to 175 grams up to 28 stone, still having a lower pressure, mainly in the thigh area, but less in the vulnerable IT area. In comparison with the foam cushion, we can see that we have extremely high pressures in the vulnerable IT areas, ranging up to a peak, up to a maximum of plus 200 millimeters of mercury, both at the lowest range of 50 kilograms or 8 stone, up to 12 stone. So concentrating mainly in the IT area, you can see the difference between a flat cushion and a recessed cushion, that the IT area is the area that is taking the highest pressure, highest peak pressure, both in all types of flat cushions. And the most effective profile of a cushion is a shaped cushion to reduce peak pressures in the vulnerable IT areas. On the right, we can see a comparison between viscoelastic foam cushions, whereby even at lower pressures, the peak pressures still occur in the IT area, and in the Airospring spacer cushions, the IT area has a much more reduced area of peak pressure in those areas, ranging from as low as 17 millimeters of mercury up to 32 millimeters of mercury. So from the profile of our cushions now, we can see how the human body fits into those profiles. The IT sits neatly beneath the recessed area, and the remaining part of the cushion, including the moulding effect characteristics of the spacer fabric, along with the additional features of the abductors and adductors, create a moulding effect of the cushion and support the person in a proper and upright position, as well as protecting the vulnerable IT areas. So, as mentioned before by Charles, because of the nature of the Airospring Pro cushions, they need to be able to resist flame. One of the things that was looked at was the burning behaviour of spacer fabrics and the combination of spacer fabrics. So in the research, I used a modified Mydrid test, which applied a burner flame to the surface of the fabric for a number of seconds, removed it, and we could watch the burning behaviour of the fabrics and layers of fabrics to see how long they burnt or whether they self-extinguished. So initial research was done in sections of the combinations, assemblies of the cushions, starting with the outside layer, going further into the main core of the fabric. So this first diagram shows the assembly made up of the outside PU fabric with the flame retardant layer and the next 3 layers of spacer fabric, with the 5th layer representing the beginning of the core of the cushion. So after the flame was applied for 10 seconds, we can see the flame reached as far as the FR layer and stopped and didn't reach any of the spacer layers beneath. At application of 20 seconds, we can see it managed to burn through to the 4th layer, beginning to scorch the 4th layer, which is the secondary layer of the spacer fabrics, which after 20 seconds self-extinguished. These series of tests, which is only a quick snapshot of the results, there was much more done, was able to give me an idea of what combination of layers was the best and effective for reducing, increasing flame retardancy and establishing the ability of the cushions to pass the CRIP 5 test. We can see this diagram shows the combination without the PU layer using the spacer fabric cover only, and we can see that after 10 seconds it reached the first spacer layer. All 3 of these cushions have been tested and now are compliant to CRIP 5 tests, which means that these Airospring 400 and Airospring 300 Pro, the contoured wheelchair cushions, meet the standard for compliance for going into wheelchair cushions and can be used effectively and safely in a variety of domestic and healthcare situations. So, from the conclusions of my research, I was able to establish that thicker wall-knitted spacer structures or multiple layers of different thicknesses and densities can be used to develop effectively contoured structures. Wall-knitted spacer fabrics retain their thickness over long periods of time, both static and dynamic, and this is mainly due to their superior resilience, as mentioned before. Contour cushions encourage greater reduction of pressure in the ischial tuberosity area than flat cushions. Multi-layered contoured wall-knitted spacer structures are better at reducing peak pressure in the vulnerable areas than PU foam, and they distribute pressure more evenly over larger areas of the cushion than foam cushions. Warp-knitted spacer fabric inherently possess superior thermophysiological comfort properties, and therefore, due to their high thermal conductivity and lower thermal resistance, it exhibits much higher thermophysiological comfort properties than PU foam. Warp-knitted spacer fabrics are much more breathable and create a much more comfortable substrate for pressure relieving cushions, and they're also extremely efficient at dissipating both water vapor, moisture away from the body. They, as mentioned before by Charles, they are extremely recyclable, being made of one fibre type only, and as I've just mentioned, they're flame retardant. Thank you for your attention, and are there any questions?